Rebecca, can you lead the prayer?
Let us pray. In the name of the Father, and Son, and Holy Spirit, amen. Our Father, who is in heaven, hallowed be your name, your kingdom come, your will be done, on earth as it is in heaven. Give us our daily bread, and forgive us our trespasses, and lead us not into temptation, but deliver us from evil. In the name of the Father, and Son, and Holy Spirit, amen.
Amen. Sit down, class. Before we proceed, I will introduce to you my colleagues. I am Beverly, and she is Shalomay. Ma'am Shalomay and
Chris.
Chris. Okay, thank you, sir. Thank you, ma'am. So we have here a attendance sheet. Kindly pull up the attendance sheet and pass it from first row to the last row. Now, what was we discussed last meeting? Okay, Ms. Eva, last meeting we discussed about the Newton's first law of motion, which is the law of inertia. Okay, thank you. Do you have any questions on our lesson last meeting? No, none. Okay. So, now, since you don't have any questions, we will have a game. This game is called the League of Quiz. So I have here a flashcard with the letters ABC written in it. So what you will do is to group yourself into two, count 1, 2, 1, 2 until the last person at the end, and you will answer the following question that I have given to you. Is it clear, class?
Yes,
ma'am. Okay, so count 1, 2. 1, 1,
2, 1.
2. Okay. Please proceed to your group names. This here is the group 1 and there will be the group 2. Students, are you ready?
Yes, ma'am.
Okay, let's begin. Question number 1. The property of a body to resist change in motion. A. Mass. B. Weight. C. Volume. D. Inertia. Again, the property of a body to resist change in motion. A. Mass. B. Weight. C. Volume. D. Inertia. Kindly raise your flashcards. Okay, thank you. The two groups have the correct answer. Now, let's proceed to question number 2. Inertia refers to blank. Inertia refers to blank. A. Force that keeps stationary object at rest. B. The force which keeps moving objects in motion with a constant. C. The tendency of moving objects to remain in motion. D. All of the above. Can you raise the flashcards? Okay, thank you. Let's proceed to the question number 3. Because of inertia, a resting object will remain at blank. A. Rest. B. Constant. C. Spool. D. Inertia. Again, because of inertia, a resting object will remain at blank. A. Rest. B. Constant. C. Spool. D. Inertia. Kindly raise the flashcard. Okay, thank you. Both groups have the correct answer. It seems you really understand our lesson last meeting. Let's have question number 4. Because of inertia, a moving object will keep blank. A moving inertia blank. A. At rest. B. Moving. C. In one spot. D. Inertia. Can you raise the flashcards? Okay, you've got the correct answer. Now, let's have the last number, the final round. Question number 5. Objects with greater blank also have greater inertia. Objects with greater blank also have greater inertia. A. Speed. B. Mass. C. Temperature. D. Friction. Please raise your flashcards. Okay, thank you for your answers. You've got the correct answers. So, please take So, okay, class. How do you find the activity? Is it good? Yes. Is it good?
Yes, ma'am.
Okay. If you say so, let's proceed to the next topic. Can you please arrange the chairs? Okay. Okay. Are you ready? Okay. We have here a toy car. What you will do is to make the toy car move forward, or you can also manipulate the car and to change its direction by sideways. I will call on Mr. Mark as a representative for pushing the car. Okay, thank you. Can you give a clap for Mr. Mark? Okay, thank you, Mr. Mark. So, by doing the activity, what will you observe? Okay, thank you. Ms. Andrea?
will move or run when we do a push or pull.
Very good. What else? What else? Anyone? Is the car didn't move unless it applied force? Yes or no?
Yes, ma'am.
Yes, it is. Very good. So when you push the car, does it change its direction?
Yes, ma'am.
Thank you. So, does it change its speed?
Yes, ma'am.
Okay, very good. Now class, what will happen if the car changes its direction and speed? Okay, Miss Erica.
It changes its velocity.
Okay, thank you. Correct. And when it changes its velocity, what will occur?
When there is a change in velocity, acceleration increases.
Okay, thank you. Now, I will call Miss Teacher Ella to continue our topic for today.
I will continue our topic to discuss further the topic of acceleration. I will present to you the objectives. Ms. Erica, kindly read. Objectives. At the end of the lesson, the students will be able to describe the Newton's second law of motion, determine the relationship between force, mass of the object, as well as the acceleration, calculate the amount of the force applied and the mass of the object, as well as the acceleration, demonstrate teamwork in performing the different group activities.
Okay, thank you.
Now class, you see I have two balls in my hands. One is a soccer ball and the other is a takraw ball. So I will divide you into two groups, and the earlier groups will also suffice if you want. And can you proceed to your groups earlier? Thank you.
Thank you. So the first set, I will just say the rules. The first set of representatives in each group will hit the ball, of the ball with less force, and the second set will hit the ball with more force. So in each group there will be first set and second set. So the first set will be you and first set, and the second set will follow. So the rest of the members will observe, so that afterwards I will ask about your observation and you can explain what did you observe about their performance. So in group 1, can you, here, come here. Step 1, just kick the force in that direction with less force. 1, 2, 3, go. Okay. Set B. Set B. Come here. Kick the ball with more force, just not, but more force than earlier. Go. Okay, thank you. Observation about the performance. When kicking the ball with less force, what happens to the soccer ball? When kicking the ball with less force, so in these two balls, which do you think is denser, the soccer ball or the takraw ball? Ang mas bugat. Soccer ball. Soccer ball is denser than the takraw ball. So when kicked with less force, what happens to the soccer ball? Did it fly slower or faster?
The soccer ball flies
Slower, very good. And what will happen to the takraw ball? Did it fly faster or slower? Faster, very good. How about the second set, when the balls were hit with more force? What happens to the soccer ball?
The soccer balls move slow.
The soccer ball move faster and further and move slower than the takraw ball. And what about the takraw ball?
Moves faster.
Moves faster and further than the soccer ball. Very good. So, what can you infer about your observation? What can you infer about the observation? Kung mas bugat, the denser the ball, the slower it moves. So, what else? The greater the force applied, the farther it flies. Very good. So, what do you think is the law that supports this hypothesis? Very good. So, what is the Newton's second law of motion?
The Newton's second law of motion is the acceleration of an object. A force applied to an object at rest causes it to accelerate in the direction of the force.
Very good. So the Newton's second law of motion states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. So the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass. So with greater force, the farther it flies, but when it's denser, it moves slower. Very good. So can you give me an example where Newton's second law of motion is applied? Riding a bicycle. Very good. So how does the concept of Newton's second law of motion apply to riding the bicycle?
Newton's second law of motion states that accelerations happen when a force acts on a mass. The bicycle's the mass are like muscles pushing on the pedals of your bicycle is the force.
Correct. Now, let's go back to the activity that we performed earlier. So which ball experienced a greater change in motion when kicked with the same force? First is the less force. Greater change in motion. The activity earlier, which ball experienced a greater change change in motion? The takraw or the soccer ball?
The takraw ball.
Very good. The takraw ball because it is smaller and lighter. So an object state of motion can be considered to its velocity. So what is velocity?
Velocity is the speed of an object with respect to its direction.
Yes, very good. So object at rest, for example, the balls in my hands have no velocity because they are at rest. So when they are kicked, their state of motion changes. When their state of motion changes, it changes its velocity. And when velocity of an object changes, that's when acceleration happens. Is it clear, class?
Yes, ma'am.
Okay, so can you explain the relationship between force, mass of the object, and acceleration?
The acceleration of an object as produced by net force is directly proportional to the magnitude of the net force. In the same direction is the net force and inversely proportional to the mass of the object.
Correct. So what is the net force?
Net force is the sum of all forces acting on an object in a particular direction.
Correct. So the net force is the sum of all forces acting on an object in a particular direction. The formula of a net force is F net or net force is equal to mass times acceleration. So what is acceleration? Acceleration is a change in velocity. The formula for getting the acceleration is A is equals to F net divided by M or mass. And also the formula for getting the mass is M is equals to F net divided by the acceleration. Is it clear, class, the formula?
Yes, ma'am.
Okay, so if it's clear, so can we answer the problems now?
Yes, ma'am.
So we have sample problems. In this one is the car has a mass of 2,500 kilograms and a force of 5,000 newtons. How fast will it accelerate? So the formula for Newton is N is equals to meter times kilogram per second squared. So may formula sa Newton. So substitute and solve. So the formula, the Newton is 5,000 and the mass is 2,500. So 5,000 divided by 2,500 is 2. So the acceleration of a car that has a mass of 2,500 kilograms and a force of 500 newton is 2 meter per second squared. So the number 2, imagine a car was going to north with 10 newton and it is pulling a parachute going to south with 7 newton. What is the net force? Can anyone answer? Thank you. So the net force is 10 newton north, and when the forces is in opposite going in opposite direction, we will subtract. So 10 newton going to north and 7 newton going to south is minus 10 minus 7 is 3. So the overall net force is 3 newton going to north. And question number 3, what is the mass of the object if the net force is 28.8 newton and the acceleration is 32.0 meter per second squared? Can anyone second or per second squared. So the answer is 900 kilograms because 28,000 Newton is what? Newton is this formula, meter per kilogram times kilogram per second squared. So we will break down this into meter kilogram per second squared. So the unit used for acceleration is meter. So cancel out ang meter. So ang mabilin is kilogram per second squared na lang. That is why 28,800 divided by 32.0 is 900 kilograms. Is it clear? Okay. So the rest of the discussion will be continued by Mr. Ali.
Okay, everyone. So further discuss the topic which started by Miss Liberty Panashal and Miss Shiraka employee. So I will sum up your ideas and learnings to the lesson. So again, class, may I ask you, what is the Newton's second law of motion? Okay, the answer please.
The Newton's second law of motion states that the acceleration of an object as produced by a left force is directly proportional divided to the left force in the same direction as the left force and inversely proportional to the velocity of it.
Yes, you're right. Okay, class, what is velocity? Okay.
Velocity is the speed of an object with respect to its direction.
Okay, very good. So what if I will sum up this? Is there a velocity with the object is at rest? Or meron bang velocity kung ang isang bagay ay nakapondo na? No? Yes, you're right. Very good. You're very good. Listen. So, for further, what is the relationship between velocity and acceleration? Okay?
Acceleration is the rate of change in velocity, which means when velocity changes, the acceleration exceeds. And an object is changing its velocity, and when changing its speed or changing its direction, when it's said to be accelerating.
Okay, thank you, ma'am. So, it is correct. So, what if a mass is constant? How does acceleration occur? Somebody else? Okay, Mr. Dilara.
The force is applied to the object.
Okay, thank you. So, very good. It's clearly that you are listening to that discussion. So, I can see now that you are really understand our lesson. So, this meeting, so to prove that you really understand, so let us again. So, are you familiar with Bumble Paper game? Yes? So, are you familiar with mini music? So, what music are you really familiar with now? Like Bobo? Okay, let's sing Bike Bobo. So, familiar mo rin yung game?
Yes,
So,
sir.
and your choosing song is Bike Bobo, right? So, when this ball is passed, you will sing the song Bahay Kubo. And when I say stop, the one who get this ball shall answer the questions this different song. Okay? Is it clear?
Yes, sir.
Okay. So, the students who hold the campus paper will have to answer the questions. So, let's start. So, the chosen song is Bahay Kubo. So, okay, let's see Bahay Kubo.
Bahay kubo, kahit munti, ang halaman mo.
Okay, can you... Okay, write it to the board. So, okay, thank you, Miss Japa. So, discuss this. So, let's recall first the formula. So, what is the formula again? Acceleration is equals so once in opposite directions, what will be the using? So, Japa, can you read the question, please?
Consider a 10 kilogram object force to the left with 10 newtons and to the right with 20 newtons. What is the acceleration of this object?
So, for the given formula, the acceleration is equal to net force over mass. So, the given is 2 newtons, right? And 10 newtons to the left. So, if it is opposite direction, what will be using subtraction? And it is correct. So, to proceed, what do you do? Subtract. So, right. Minus 8. Certainly, it is correct. So continue. This same song again, sa bahay kubo.
Bahay kubo, kahit munti, ang halaman doon ay sari-sari, singkamas sa tanim.
This read the question.
Determine the acceleration that results when a 12 Newton net force is applied to a 3 kilogram object and then to a 6 kilogram object.
Okay, thank you. So, if a triangular object experiences an acceleration of 4 meters second squared or MSS, it is a 6 kilogram object experience an acceleration again to 2 meters second. So, certainly, so it will. So, if the Newton, so what is the formula again about this? And it is correct. So let's continue the game. Let's sing again the Haiku.
Bahay kubo, langit munti.
Stop. So can you please stand? Get one. Okay, it's a bonus. Okay, let's sing again the song. But fast it again.
Bahay kubo, langit munti. Ang salaman doon ay salis.
This is the question, please.
And that course education is exerted on an encyclopedia because to accelerate at a rate of 5 meters per second squared, determine the mass of the encyclopedia.
Take it up to the board. So, okay. Again, what is the formula of this given problem? So, by the way, class, in this problem, it changes. We use the net force. Net force equals to mass times acceleration. Why? Because we're calculating the rate. So, we interchange. So, we use the multiplication for this equation. So, net force is equals to 15 Newton and acceleration is equals to 5 meter per second. So, what is the net force in this given problem? 15 Newton. So we put the 15 Newton in this place, and then what is the acceleration? 5 meter per second. So we interchange. So we divided it into 15. 15 and now it's 5 meter 5 then 5. Why we divided into 5? Because to cancel out this meter per second, to para maiwan si mass. So the answer is correct. Mass is equals to 3.0 kilogram. So why is it 3.0 kilogram? Because 15 divided by 5 is equals to 3. And it is correct. So again, let's sing the song and pass the crumpled paper again. Let's sing song again.
Bahay kubo, kahit munti, ay halaman doon, ay sari-sari, sikamas at talong, sigarilyas at
Okay? Okay, can you read the question?
Acceleration is equal to net force over.
Okay, that's correct. But first, in this problem, you will use the net force equals to mass
Times
times acceleration, then equals to acceleration equals to
force net.
F net or net force over mass. So, actually, this answer is correct. Okay, so are you satisfied on this activity?
Yes,
Yes,
sir.
Do you enjoy?
Yes, sir.
To continue, so let's have an evaluation. So, this is evaluation. So, complete the table below. Complete the table below using the given value and find the acceleration, the mass, and the net force. So, I will give you an answer card. So, class, copy and answer this table. So, I will give you a 10 minutes to answer this task. So, your time starts now. Okay, students, are you done? Okay, can you fast forward your screen, please? Okay, can anyone can go to the board to answer this question? Okay. Okay, class. Your answer is your answer is okay. So, class, is your answer is 5 in this table? Okay. How about number 2? Is it 10?
Yes,
sir.
How about number 5? Is it number 1?
Yes, sir.
Okay, so I see that you are clearly listening to the discussion of our previous teacher. So before we end our lesson, so we have an assignment. So please read Miss Erika.
Determine the acceleration that results in 824 acceleration 54 net force. The Newton net force is applied to 8 kilogram object and then the 4 kilograms object.
Okay, thank you. So this assignment must be submitted before the class started or class dismissed. Thank you.
Goodbye and thank you, sir.